Okay, dah start record. Good. So, today kita akan masuk new chapter. A new chapter in your life juga, kan? Datang college. Alright. So, nanti kalau ada any question terus tanya. Because kalau korang tanya teks takut saya tak nampak ni. Saya guna laptop college ni. Okay, semua dah makan kan tadi? Dah habis dah makan dekat cafe. Okay. So, let's start our class. Okay. So, first yang kita akan belajar today, which is chemical equilibrium. So, apa tu chemical equilibrium? Can see. So, chemical equilibrium just means that equilibrium ni maksudnya itu just means that it is the same. Okay, the general terms is the same lah, or what can we say? Seimbang. Okay, in Malay is seimbang. Okay, maksudnya kalau in chemical terms, which is the product and the reactant is seimbang. Okay, so we will see this kind of arrow a lot. Okay, which is half arrow. Okay, tak kisahlah you nak start macam ni. Apa jadi tu? Nak start macam ni ke ataupun macam ni ke, it is acceptable. Doesn't matter. It just that to show that chemical equilibrium, our arrow is half arrow and atas bawah lah. So kiri and kanan ditunjuk dia. So in chemical equilibrium, we have three things.
Sir, screen sir tak bergerak sir.
Tak gerak ke? Ayo, sekejap Thank you beritahu. Kalau ini, I hope you guys boleh nampak. Saya pun dah tak sabar nak buat kelas physical. Nyampah dah tengok laptop ni. Okay, nampak tak? Kalau saya gerak-gerak cursor saya ni. Nampak ke?
Nampak sir, nampak.
Okay, good. Thank you bagi tahu. So, this is yang kita nak belajar. So, tadi saya cakap equilibrium mean like seimbang, which is like pretty much equal lah. Okay, but equal in terms of what we will see. Okay, in this chapter we have three yang kita akan tengok. So we have dynamic equilibrium, equilibrium constants, and Le Chatelier principle. Okay, so we have three things ni, but today I think I want to focus on 6.1 and 6.2. Le Chatelier ni maybe at the end of this week kalau kita sempat. And actually we already see this principle. Okay, kalau korang remember, do you remember ini diagram apa? Ingat tak ini diagram apa? Manakah pelajar saya? Saya rasa korang ada kan dekat sini.
Phase diagram nak?
Yes, phase diagram. Okay. Hari tu, phase diagram is actually a concept that came out from Le Chatelier principles. Okay, Le Chatelier principles ni is also based on chemical equilibrium, where dia cakap everything usually in a closed system, dia orang nak jadi equal. Okay, kalau boleh dia orang nak tenang lah, dia orang tak nak gaduh-gaduh. Okay, so this is learning outcome untuk 6.1. Kita akan tengok reversible reaction, dynamic and law of mass of action. And then state the characteristic of system in equilibrium ni kita akan tengok nanti, and curve, concentration of reactants. So this there is a graph yang you might kena buat. So question usually akan sketch. So remember kalau sketch you only have to draw cantik-cantik and tak perlu apa benda ni? Okay, you only have to draw cantik-cantik and not bukannya kena guna graph paper lah. So, let's masuk dynamic equilibrium. Okay. Sebelum ni, we did a lot of equation semua. Kita balance the equation. a lot of the kalau most of the time kalau you guys nampak, we use single arrow. So arrow yang menunjukkan the reactions are progressing from A and B into C to D. Okay, this is very kebanyakan macam ni. Okay, so it means that it's only take one direction, right? Once the A bercampur dengan B has already reacted and become a product of C and D, C and D will not become A and B back. That will not happen. It just forever C and D just will be C and D lah. Okay. So this is one example. Is the chlorination of methane. Okay. But now, they found out some of the reaction not only go forward, but also can go backward. Okay, so it means that contohlah A, okay, kita panaskan dia ke apa, it become B, and B also can kalau kita tinggalkan, it will turn back into A. Okay, this is a very simple explanation of reversible reaction. Okay, it means that A and B does not completely react. Okay, kita tak ada limiting, tak ada excess reactant here. Because sekarang bukannya ke semua A jadi B, we will have some of A yang akan jadi B and some of B jadi A, vice versa lah. So dia orang akan keep bertukar. Never ending cycle. Okay, so we have terms lah where nanti kita akan tengok equilibrium constant where it is important. So untuk daripada kiri ke kanan, like how we baca, we read our books, we call it forward reaction from left to right. Okay, and reverse reaction is from right to left. Okay, it will be the same if kalau B di sini, this one, so kalau in this term pula, B ke A will be the forward reaction, while A ke B will be the reverse. Okay, it just that how kita tulis the chemical equation will dictate which one is forward, which one is reverse. Okay, so right, so this is an example of reversible reaction lah. So hydrogen gas dengan iodine gas to make hydrogen iodide. Okay, and this acid also boleh patah balik menjadi gas dia. Okay, so that's just an example. Okay, so kita ada forward and kita ada reverse reaction kan. So kita ada forward and kita ada reverse. So we have two things sebabkan the way kita tulis the chemical equation, we have two reaction lah basically that happen at the same time, right? So in terms of question ataupun statement yang diorang bagi dalam chemistry, kalau we will see that anything yang kita tulis dulu, it means it is a reactant, and what is yang tulis afterwards, which is belah kanan, which is the product. So we will assume at the start of the reaction there is no product. Okay, that means that everything, contoh dalam that one beaker, we only have the reactant. Okay, so in a reversible reaction, kita assume that at the start of the reaction we don't have any product, we only have reactant. So the first thing that will happen is the forward punya reaction lah. So the forward will happen first, where the reactant will combine, tak kisahlah 1 ke 2 ke 3 ke 10 ke, will combine and will produce a product. Okay, but at one point the product will be more than the reactant. So what happened? The product will start to turn back into the punya reactant, which is the reverse reaction. Okay, sounds weird, but it's actually happening lah. So just imagine like this lah. So imagine a seesaw, this. Okay, you ada you punya reactant, you ada you punya product. Okay, you keep converting reactant into product. Okay, we have more and more product, and now the product start to become heavier, and the seesaw will start to tilt the other way, right? Start to tilt this way. Now what happened is dia punya product will start to turn back into reactant, because in any system they orang prefer untuk be in equilibrium, which is equivalent lah on kiri dan kanan. Okay, so this is example of the graph yang diorang maybe akan suruh sketch. Diorang akan give you a reaction, well, not a reaction, and chemical equation, and diorang suruh sketch a graph. Okay, so don't worry, this one is kalau just kita akan masuk on 6.2. So this is reaction equation. Sekejap, saya rasa macam saya salah eja tu. Okay. Ini bukan, ini saya salah eja. So it is QUOTIENT, reaction equation. So it's just same thing as K lah, and K is equilibrium constant. Equilibrium constant. Okay. So untuk yang graph yang diorang suruh sketch, which is diorang akan usually akan tanya concentration versus time. Okay, remember any graph sketch ke ataupun plot, you always have to ada title, which is concentration versus time, and this cara is kita to denote concentration. So contohlah kalau HCl, untuk denote the concentration of hydrochloric acid is we use bracket yang petak. Kenapa ni? HCl. So this is how kita denote concentration of HCl. So in a bracket of B, it means the concentration of B lah. So how the reaction proceed? Ingat tak? The very first time we only have our reactant, kan? A is our reactant. So by the times go, the reactant will start to become less and less. Kenapa? Because the product are being formed. So remember, kita akan start at the very axis, and product will always start dengan 0. Okay, so as we have less and less reactant, we start having more and more product, and more to a point. Okay, to a point where we achieve equilibrium. Okay, where we achieve equilibrium is when the rate, the rate to from A ke B and B ke A is the same. Okay, and how we know the rate of changing A ke B and B balik ke A? Rate dia constant. Kita tahu rate dia constant of A ke B and B ke A is when dia punya concentration of A and concentration of B dah jadi constant. Okay, but the common mistake yang a lot of student do is dia orang cakap at equilibrium the concentration of A is equal to concentration of B. Okay, this is not true. Okay, at equilibrium concentration of A and concentration of B mungkin sama, tapi not always sama. Okay, at equilibrium apa yang sama is the rate. Okay, kadar is the kadar, which is the rate of A changing to B and B patah balik ke A. Okay, A tukar ke B and B tukar ke A balik. Okay. So this is the yang kalau point dia lah. This is when equilibrium happens, which is it is seimbang. The seesaw dah seimbang. Dia tak ada anything yang turun bawah lah. Okay. So, but does not mean the reaction stop. Okay. Even though the cut here we already achieve equilibrium. Okay. So that's a symbol for equilibrium lah. E with triple lines. Okay. So at equilibrium does not mean the reaction stop. The reaction does not stop. It just means they keep constantly bertukar each other, but now they want tukar at the same rate where the concentration dah tak berubah. Okay. So, another definition of equilibrium is a state where there's no observable change lah. So, kita ada two types of equilibrium. Kita akan tengok. Tadi yang kita bincang is chemical equilibrium. Chemical equilibrium, where kita tengok dia punya concentration. Okay. But now we also have physical equilibrium. Okay. Physical equilibrium. Remember phase diagram. Okay. Phase diagram. Okay, at the lines we have physical equilibriums where the gas, contoh this one is solid and this one is gas. So at the lines we have physical equilibrium where the rate of transfer, the rate of change from gas to solid to gas is in equilibrium. And we also can denote it dalam chemical equation like this. So H2O liquid, which is L, and H2O gas is in equilibrium. Alright, in chemical equation, saya perasan juga dalam you guys punya assignment, always tulis dia punya phase. Okay, phase which is this. Okay, very easy. Untuk L which is L, sometimes kita tulis ni, is only for water in liquid form. That's it. Okay. Anything yang kalau ada contohlah, kalau anything yang ada one atom and ada dua, O2, Cl2, Br2, okay, kalau you tak tahu, it is most likely a gas. Okay, dalam bentuk gas. Alright. Kalau lah contoh dia bagi HCl, you tak tahu HCl ni in gas form ke apa, you just tulis it is in aqueous form. Alright. Phase is very important in chemical equation. Okay. Some pemeriksa is quite picky. Kalau even though you punya reaction betul, seimbang, everything, you tak letak phase, you might dapat kosong, markah. So that is a bit about a bummer lah. So, and chemical equilibrium yang kita tengok tadi. So, if you present one here, air bertukar ke gas, the container is sealed, and also in chemical equilibrium there's also we cakap in sealed flask. For an effective equilibrium, we always look in closed system lah. Closed system. Kenapa saya salah eja ni? System. Okay, apa jadi ni? Okay, in a closed system, because kalau in an open system, it will take forever untuk dia be equalized dengan atmosphere lah. So in a closed system, we can directly nampak dia punya the equilibrium point. Okay. So this is just an example of equilibrium of N2O4 become ke nitrate gas lah. Untuk this is not only liquid, we also can see it in gaseous form. Okay. So at the start, they start dengan colorless, they become more and more brown. Okay. So the point where it is achieved equilibrium is when we observe no more change. So the color that become constant. Okay. So that is pretty much a dynamic equilibrium lah. So remember that this is the most important punya point where the cut equilibrium does not mean the concentration is the same. It just that the rate of forward reaction is equal to the rate of reverse reaction. So kita dah tak ada, we observe zero change in diorang punya concentration lah basically. Okay. So we have a few examples of graph yang you might boleh tulis lah, lukis, sorry. So the first is the typical one, which is yang saya tunjuk tadi itu. So we start dengan okay. So this one, it means that dia punya forward reaction is here from NO2 ke N2O4, while dia punya reverse reaction is here lah. Okay, because nampak tak? Dia start dengan NO2. So we have, okay, any graph yang tinggi, which is kita akan start dengan, so this will be dia punya reactant and this will be the product, where reactant akan start berkurang and product akan start bertambah lah. And for here is vice versa, which is kita ikut this one, kita start dengan N2O4, sorry. And cara nak lukis is pretty much, you kalau dia bagi value, you letak lah. But as long as the shape is correct, is fine. The thing yang you need to know, the thing yang you need to have in your punya graph is you have your punya title, label your punya axis, complete with dia punya units, which is unit of concentration and unit of time. And another thing yang you need to label in this is here. Kalau you dah nampak, you can label it with a dotted line, guna pembaris, jangan jadi malas macam saya. So this dotted line, it just to show is when is the equilibrium happen. Okay, so it is when the concentration dah tak berubah, the concentration stay constant. Okay, and we also can have dalam beaker tu, awal-awal tu kita dah ada dua-dua. So we have NO2 gas and N2O4 gas at the same time. So in the beaker, in the closed beaker, we already have the two gases, and the two gases will start changing to each other. And the thing, the thing pula lah, dia punya gradient you should draw a bit linear lah. Maksudnya tak too much gradient lah. So dia punya reactant start berkurang, tak banyak sangat, and start becoming constant, and the product start bertambah and start jadi constant. So if you want to know kenapa sometimes dia akan start atas start bawah ni, okay, it depends on the question. Sometimes dia akan bagi tahulah N2O4 ni lagi banyak, so dia akan start dekat lagi atas daripada NO2. Okay, so this is, so that one yang question yang maybe 1 mark, 2 marks, or maybe even 3 marks tu. Untuk question yang banyak marks is coming from law of mass action, ataupun this law of mass action is sometimes they call it equilibrium law. Okay, so okay, you guys boleh baca benda ni panjang, but a simple terms that is, okay, kita nak tahu equilibrium constant. Okay, we plot a graph, usually we will have a constant. Okay, so it's just saying that equilibrium constant, which is K, okay, yang kita tengok tadi, is equivalent to dia punya concentration of product. Okay, so product darab concentration of Kalau ada banyak produk, daratlah banyak produk. Doesn't matter. So D. Okay. And this concentration must be to the power of dia punya stoichiometric coefficient. So remember you balance the equation, the stoichiometric coefficient dekat depan. So kalau concentration C must have the power of C and concentration of D must be the power of dia punya stoichiometric dekat depan, and dibahagikan dengan concentration of reactant to the power of dia punya stoichiometric coefficient, and likewise. Okay. One thing to take note, okay, because later on kita akan tengok we have two. We actually look on concentration and also pressure. Okay. So sebabkan kita boleh tengok concentration and also pressure, we need to denote equilibrium constant ni is kita calculate based on apa. So since kita tengok on concentration, dia letak Kc. So Kc maksudnya it is equilibrium constant based on dia punya concentration. Okay. And kalau remember tadi, gas pun boleh ada equilibrium kan. So that's why we also can have Kp. Okay. Kp we will look nanti later lah. So if you remember, we also have Dalton law of partial pressure, where kita tengok partial pressure of each component. So Kp kita akan tengok dia punya partial pressure and also dia punya stoichiometric coefficient, sama je. But first kita tengok dulu equilibrium constant based on dia punya concentration. So okay, and remember this is just how we denote concentration. Okay. And one more thing untuk this kind of question, the very important thing, okay, is unit. Okay, nanti kita akan tengok because unit dia tak sama. Unit untuk KC ni tak sama based on you punya reaction. Okay, we will do an example later on. Okay, first of all, macam biasa, any question involving equation, always check dia punya seimbang or not. Alright, so this one dah seimbang. So cara nak cari dia punya equilibrium constant is the concentration of dia punya product, okay, darab dengan dia punya stoichiometric coefficient, which is now is only 1 lah. Tapi dia orang tak tulis lah kan. Kalau tak tulis tu maksudnya 1. Okay, and anything to the power of 1 will still be the same kan. So tapi in this tulis lah, you tulis to the power of 1. Okay, because jalan kira also can give you marks. Okay, to by writing 1 does not mean it is necessary to write 1 lah. I'm just telling you to write 1 so you remember that we need the stoichiometric coefficient as dia punya power. Kalau tak nanti korang lupa, takut korang just terus buat dia punya concentration without any regards to dia punya stoichiometric coefficient. Okay, so this is another example, okay, where it's like this lah. Okay, so untuk unit dia, okay, unit concentration concentration, okay, apa ni saya salah. Okay, can anyone let me know the unit of concentration? Okay, unit of concentration. Tolong bagi tahu. Apakah unit on concentration? Okay. The other perkataan of concentration, which is kalau you guys remember, is also tension saya. Molarity. Okay. What is the unit of molarity? Korang ada ke? Korang tak nak jawab, saya cari korang. Apa unit dia? Wahai anak-anakku, unit concentration or molarity, which is mole of solute over volume of solution kan? Solution. So, unit of concentration is mole per liter ataupun mole per dm cube, or ataupun it is m besar, which is 4 molarity. Okay, so usually dia orang akan tanya dia punya unit. So unit of Kc, so you kira-kira nanti dia akan bagi tahu you punya answer and you punya unit need to be stated. No unit, you jawab tanpa unit, there's no point of you jawab. You just wrap the paper and just throw it lah. Okay, because you're not gonna get marks. Okay, cara nak tahu dia punya unit is not always the same, because you need to figure it out based on dia punya equation. So for this, for example, this punya Kc, right? So cara nak figure out dia punya unit is dalam cara senang is dalam calculation tu you terus masukkan lah. But another way is you masukkan it is mole per dm cube, right? Squared over mole per mole dm cube squared, and then mole per dm cube squared. Kuasa 1. So kalau you guys tengok, kita boleh cancel out the unit, right? Kita boleh cancel out this and kita cancel out this. So at the end, dia punya unit is per mole and dm cube. This is dia punya unit. Ataupun kalau you guys rasa macam alamak pening, remember that molarity also can be denoted as m. So it's easier kalau you nak buat macam m kuasa 2 over m kuasa 2 and m kuasa 1. So just cancel it out. So the unit will be m negative 1. That is dia punya unit. Okay. Untuk equilibrium constant, bukan bermaksudnya every equilibrium constant dia punya unit m negative 1 tau. It's completely based on equation. So if you guys remember, look at this. Okay. Untuk this equation, apa dia punya unit? Alright. Korang boleh buat tak? Tolong carikan unit untuk Kc. Apa unit dia? Apa unit dia? Okay, betul ke? Cuba masukkan balik and cancel it out. Yes. Sam dengan kali. Betul. Because tak semestinya Kc tu ada unit. Even though saya point out that korang tadi tak ada unit tu, korang boleh bungkus ke apa ke. Tak. Okay? It is based on dia punya equation. Sebab, you look at here. Tension saya. Okay. So, M. Apa kena lah benda ni? Kuasa 1 dengan M kuasa 1 over M to the power of 1 and M to the power of 1. You cancel it out, it will have no unit. Sebab unit dia cancel out each other. So equilibrium constant, the unit of equilibrium constant is purely based on the equation itself, and you have to find out. And it's not that hard pun. So kalau you susah, you guna M saja daripada nak guna mole per dm cube. Okay. So okay, this is yang sometimes question will ask on the early question lah, question 1, question 2. So question akan tanya the characteristic of a system in equilibrium. Okay, remember tadi saya cakap the very first thing is it is in a closed system, because it's easier nak sampai di equilibrium comparing kalau kita just tinggal dia at open space lah. Okay, so in equilibrium, the thing yang kita tengok is the concentration of the reactant and the products are constant over time. But this one is only for liquid lah. Liquid punya phase. Okay. Kalau gas, we just say that the conversion of gas, the partial pressure is the same. Okay. Kalau gas, we talk about dia punya partial pressure. Partial pressure. Okay. The thing yang kita talk about the most in equilibrium is the forward rate of reaction is equal to the reverse rate of reaction. Okay, that is pretty much the definition of equilibrium. Okay, this thing saya tunjuk tadi, reaction quotient is equal to the equilibrium constant. What is reaction quotient? Saya rasa macam saya dah cakap Mandarin lah. Okay, so this Q, okay, is the same thing as cara kita nak cari Q is the same thing as cara kita nak cari K, which is A, B, C squared D ke D A and then apa ni, and B. Okay, but it just that Q, reaction quotient, is at dia punya concentration bukan equilibrium. Okay, the one that we use K, the equilibrium constant, is kita assume dia punya concentration yang diberi is constant. Okay, tapi Q is where dia bukan lagi equilibrium. Okay, bukan lagi equilibrium. So before equilibrium ataupun maybe after the equilibrium. Okay, ya, ada orang masuk baru ke? Okay, so don't worry, this one kita akan tengok more on 6.2. So this is yang tadi kita tengok tu. Okay, so untuk graf ni dulu ada this kind of question. Sekarang most likely tak ada, tapi I akan confirm dengan you later, because question macam ni diorang dah dibuang from the syllabus, where diorang bagi the concentration and diorang suruh you plot the graph and find the equilibrium lah. But for the equilibrium, cara you nak cari is where you tengok dia punya ratio of product against reactant, and it should be constant. Okay, so remember it is squared. For you to get the equilibrium constant, it is squared because it is dia punya reaction stoichiometric dia punya coefficient. So K C should equal to the concentration of NO2 squared divided by the product, which is N2O4 to the power of 1. That is the reaction constant. Okay, so I think kita sempat masuk on 6.2 of equilibrium constant, and I hope kita sempat buat one ice table. So untuk ice table yang kita akan belajar ni, so kita akan belajar on homogeneous and heterogeneous equilibrium. So now tadi kita tengok is only liquid or only gas, But now kita tengok in a system where they also have gases with conjunction with liquid. Okay, kita kan tengok the Kp and Kc macam mana dia boleh relate to each other. Okay, and then we can calculate Kc and Kp and kita determine degree of dissociation ni based on ice table. Nanti kita akan tengok ice table. Right, so in a homogeneous equilibrium, tadi kita belajar semua on homogeneous equilibrium. Homogeneous maksudnya it is the same. Alright, maksudnya all of the product and all of the reactant are in the same phase. So it's either gas, all of it are gas, ataupun all of it are liquid, ataupun aqueous lah, ataupun all of it ataupun all of it are aqueous. So kalau semua aqueous, okay, it's no problem. Okay, don't worry, kita can write our equilibrium constant macam normal. Kita ambil dia punya concentration to the power of stoichiometric coefficient. Okay, sama juga untuk pressure. Okay, sometimes the question is tak bagi you in concentration, tapi they give you in pressure ataupun partial pressure. Okay, partial pressure you also do the same. You letak partial pressure dia to the power of dia punya stoichiometric coefficient. Usually this kind of thing dia akan tanya kalau all of it are in gaseous form lah. Gaseous form. Okay, so that's fine. But now apa jadi kalau it is in a mixture of gas, we also have solid, we also have gas, and we also have liquid. Okay, macam mana nak cari dia punya equilibrium constant? Okay, so contoh kalau kita nak cari equilibrium constant based on dia punya concentration. So kita tulis macam biasa, doesn't matter, tulis je macam biasa. So concentration of C to the power of C squared darab dengan concentration of D to the power of concentration to the power of D squared to the power of D, sorry, and concentration of A to the power of A, concentration B to the power of B. But know that, okay, kalau the solid apa-apa yang macam solid, okay, concentration, solid ada concentration ke? Solid tak ada kan? Solid tak ada kepekatan. So dia punya value should only be 1. Okay, so anything yang contoh the concentration of D to the power of D will be 1, sebab it will automatically jadi to the power of 0. So anything to the power of 0 is 1 kan. So that's why dia boleh cancel out je. Okay, so solid memang tak ada concentration. Okay, right, and then gas ada concentration. Okay, and then kalau L is usually anything yang H2O. So we also assume concentration of H2O and to the power of apa-apa H2O tu is equal to 1. Okay, that's it. So untuk concentration, untuk equilibrium concentration, you will get this one lah. And kalau untuk pressure, apa je yang boleh ada pressure? So gas boleh ada pressure, solid tak boleh ada pressure, and liquid also tak boleh ada pressure. So untuk yang gas, you will only left with C squared. So partial pressure of C squared over to the partial pressure of A squared. Because kalau pressure we do not have untuk liquid or aqueous form, and we also do not have pressure for solid kan. Okay, untuk concentration we only have untuk aqueous and dia punya gas. Only these two yang ada dia punya concentration. Other than that, dia orang tak ada. Okay? So, everyone clear so far ke? Okay tu. Okay. Okay, ataupun pening. Okay. Nanti dalam kelas kalau saya tanya okay, korang jawab Nanti saya dalam kelas pun saya cakap seorang-seorang juga. Okay. This thing is the previous syllabus. Okay. So don't worry. Dulu question tanya about derivation. So dia orang nak tanya that macam mana you nak relate KP and KC. Okay, dulu. But sekarang, okay, you guys should be grateful that this dah di remove from the equation. Okay, from the syllabus. The only thing you need to know, you need to hafal lah the equation takkan diberi is this, where KP is equivalent to KC, okay, in bracket darab RT, which is R is our gas constant and T is temperature in Kelvin, and R is gas constant kan tadi. Apa jadilah ni? Okay, and delta N, I need to fix my drawing pad. So delta N is the mole of gaseous product minus mole of gaseous reactant. Okay, how many moles yang ada dekat product minus dengan how many moles yang ada dekat reactant. Okay, but untuk this you tak perlulah cari moles. Okay, you tak perlu cari moles in each individual. So moles in this term, because we are, okay, K is equilibrium punya constant. Equilibrium. Okay. It means that everything now is ideal, right? Semua dah stable and sama and it is ideal. So the moles yang kita nak cari, we can terus ambil from dia punya stoichiometric coefficient. Okay. So tengok yang mana gases punya phase. Okay, sebab kalau KP and KC usually dia akan tercampur lah. Ada yang gas, ada yang aqueous. So you just take which one yang ada gas, but in this term all of these are gas. So take dia punya stoichiometric coefficient. So C tambah D. Okay, in this term dia C dengan D lah, but maybe 1 tambah 2 atau 3 tambah 4 ke macam tu, depends. And minus dengan dia punya stoichiometric coefficient of dia punya reactants. Okay, so that is the only thing you need to know. Untuk this you tak ada lagi nak derive, you just know the equation KP equal KC RT to the power of delta N. Remember, to the power bukan darab delta N. Just know how to use it. Okay, so we have 10 more minutes. And I want to show you the ice table. Okay, this is a very famous question where diorang akan bagi equilibrium question, and then disuruh calculate the concentration ataupun calculate the partial pressure at maybe equilibrium ataupun most likely diorang akan at equilibrium lah. Okay, so it is called ice table for a reason. Okay, because we are writing the table in terms of ice, which is first kita akan write the initial quantities and then the change and then the equilibrium quantities. Okay, degree of dissociation ni, it just that how many change divided dengan dia punya initial concentration darab 100. It's very simple je. Okay, but first, this is the type of question yang dia tanya lah. Okay, so I will discuss this question and I think that's it for our class nanti. Kita discuss this question dulu. So, equilibrium constant Kc for the composition of HI gas to hydrogen H2 gas is 0.04. Okay, this is Kc. Okay, at 25 degrees Celsius. Calculate the concentration of all reacting species if 0.1 moles of mole of HI is introduced in a 5-liter flask at 25 degrees Celsius. Okay, untuk this, kalau dia tanya concentration, it means that every number yang you masukkan is in concentration. Kalau dia tanya in partial pressure, you need to change everything in the same unit of partial pressure lah. Tak kisahlah ATM ke, Pascal ke. Okay. So, the very first thing in equation, in a question yang relating with a reaction, okay, you always have to write dia punya chemical formula dulu. Okay, dia cakap decomposition of hydrogen gas in hydrogen iodide into hydrogen gas. Okay, so maksudnya it is warna kuning lah pula. So here, so maksudnya hydrogen gas, okay, remember to write the phase, it decomposes into hydrogen gas, and also since hydrogen gas, iodine ni pun sepatutnya jadi have to go somewhere lah kan, so we also have iodine gas. And remember untuk tulis the arrow in this kind of form, which is a reversible form. Okay, you nampak the word equilibrium, you terus know that it will have a reversible reaction. Okay, kalau lah you terlupa and then you tulis the chemical equation like this, you will not get any marks for this. Okay, this is wrong. Okay, so before you start jawab, remember any chemical equation must be balanced. So let's balance this. Kita balancekan dulu. And kalau you tengok, this one ada 2 hydrogen, this one ada 2 iodine. This one should also have 2. So dah balance. Okay. So untuk ice table, we have 3 things. So we have 3 things yang kita tengok. We have initial concentration, we have the change, and we have the one at equilibrium. Okay, so that is yang kita tengok lah. This color. So apa je yang dibagi? Okay, which is the only bagi is all reacting species if at the very first we have 0.1 mole of HI introduced into 5-liter flask. Alright, so here you should find dia punya, sekejap So, the very first thing yang you need to get, because remember, untuk ice table, we only use is either concentration ataupun pressure, right? So, we have 2 things. So, kalau tengok ni nak tukar ke pressure macam susah je, right? And plus, dia minta in concentration. So, tukarlah in concentration. apa yang kita perlukan untuk tukar dalam concentration? Remember, concentration is equivalent to moles over volume. Right? So, we are given moles, we are given volume, we should get dia punya concentration. So, concentration of HI initially is 0.1 over 5 liter. So, you should get 0.02. Alamak, tergerak ni lah. Right? Okay. So, you should get 0.02. Okay. Apa concentration of H2 gas dengan iodine gas? Okay. Initially, at the very start of the reaction, we do not have anything. So, we should have 0. 0. Okay. Sorry ya, 0 saya ada topi. Saya nak padam pun tak boleh. Nanti terpadam semua benda. Okay. Oh, good. Okay. So, that is initial. Okay. Sekarang, apa yang change? Okay. Equilibrium. Okay. At equilibrium, everything follows stoichiometric coefficient. Okay. So, apa yang berubah untuk equilibrium is totally based on dia punya stoichiometric coefficient lah. So, this one ada 2, this one ada 1 kan? This one also ada 1. So, change dia, apa yang berubah? So, mana color tadi? It means that untuk di achieve equilibrium, dia akan berkurang sebanyak negatif 2. Kenapa it is negatif 2? It is because dia adalah reactant. So, reactant akan berkurang lah. Takkan reactant bertambah pula. Sebab dia nak bertukar menjadi produk. So, dia akan berkurang. How much dia berkurang? Is 2. Kenapa 2? Sebab it is equilibrium and we follow dia punya stoichiometric coefficient which is 2. So, dia berkurang sebanyak 2. Okay. So, we know dia berkurang banyak 2 and we know dia berkurang, ini akan bertambah sebanyak 1 and this one also akan bertambah sebanyak 1. Okay. Because of the stoichiometric coefficient. But this one does not really mean anything. Okay. Sebabnya, we need to denote unknown untuk kita cari the coefficient, untuk kita cari dia punya concentration. Okay. Because, kalau you guys tengok, takkan H2, hydrogen gas akan bertambah menjadi satu concentration. Dia akan jadi 1 molar ke? No. Okay. Because concentration yang diberi, okay, this concentration yang diberi bukan dekat equilibrium. Okay. Bukan dekat equilibrium. But, perubahan yang kita tengok is dekat equilibrium. So, untuk kita kaitkan dua-dua itu, we mestilah letak an unknown so that we can kaitkan dua-dua tu. So, we can letak, usually kita akan letak X lah. You boleh letak lah apa-apa je huruf. So, 1X. Okay. This means that at equilibrium, we will have 0.02, which is dia punya initial concentration, and dia akan ditolak oleh 2x. That is dekat equilibrium. But kita tak tahu lagi 2x tu berapa kan? Kita tak tahu. And at dekat equilibrium, we will have x and x untuk concentration of H2 gas dengan iodine gas. Okay, that is fine. Tapi macam mana nak cari ni? Aduh, peningnya. Don't worry, we still have Kc, right? We have Kc. So, kalau ni lah. So KC. And macam mana kita nak tulis KC, which is kita letak dia punya product first, concentration of H2 to the power of 1 darab dengan concentration of iodine gas to the power of 1. Tension saya. Okay, to the power of 1. And divided by the concentration of dia punya reactants to the power of 2 sebab stoichiometric dia adalah 2. Okay. So, nilai Kc dia beri. Which is 0.04. And, so kita nak cari nilai X, we just masukkan je lah. So, Kc is 0.04 is equivalent to X. Okay. So, you just letak dalam bracket ataupun darab terus je, tak apa. Okay. Untuk concentration of H2 and darab dengan concentration of iodine gas and over to the power of 0.02 minus 2x squared. So imagine benda ni tak ada Okay, so you should selesaikan untuk x dapat berapa. But kalau you tengok, okay, you darab, you will get x squared, kan? You akan dapat nilai x squared sama dengan something. Right? Tapi, so nilai x squared, kalau you dapat something, you nak cari nilai x squared, you akan square root, kan? Untuk hilangkan square. So, x equals something in square root. But we always know that kalau dalam square root, okay, you always get two answer, which is positive dengan negative punya version. Okay. Kenapa you dapat dua? Okay, sebab you factorizekan dia and you should dapat dua answer lah. Okay, just remember that untuk ice table, concentration ataupun pressure, we only take the positive punya value. Only positive value kita ambil. So, lepas ni, you kira sendiri guna calculator, you should dapat x is 2.86 times 10 to the power of negative 3. And lagi satu nilai x is negative 6.67. Hayya, 6.67 darab negative 3. But kita tak ambil the bottom one because the bottom one is negative. We only take the positive one, which is this. This is the nilai x yang kita ambil lah. Okay. So, we already know nilai x. So, at equilibrium, so the question tanya, calculate the concentration of all reacting species. All reacting. Okay. Bukan maksudnya reactant saja. Because at now, we also look on product. So, masa dah habis. So, I cepatkan So, concentration of HI is equivalent to this, kan? So, dekat equilibrium is 0.02 minus 2x. So, masukkan nilai x, you should dapat, tak nampak lah pula. You should dapat, it is 1.43 times 10 to the power of negative 2 molar. And untuk concentration of H2, you should dapat dia punya concentration is 2.86 times 10 to the power of negative 3. Like here. Sebab dia adalah only x, kan? You just gantikan nilai x sahaja. And same for iodine. Sama sahaja. Okay. And dia punya unit is molar ataupun mole per cube. Okay. Don't worry. Kita akan do more exercise based on ice table. And sorry for taking your time. cuma masuk ke Discord so that we can ambil attendance, and any question boleh tanya sana.